Good afternoon, Chris. Let me share the screen first. Today, I'm going to cover pointers in C, C++. First, let me introduce what pointers are. We all know whenever a variable is declared, a memory location is allocated to store the value of that variable. So, in short, a pointer is the memory address of a variable. How we got the name is because a pointer points to a variable by telling where the variable is located. Next, let's learn about how to use pointers. First, pointer variables must be declared to have a pointer type. Let's check the example here. To declare a pointer variable, PTR, that points to a variable of a type integer, we need to type like this, like the statement in red, int asterisk PTR. So by putting the asterisk here, the asterisk identifies PTR as a pointer variable. So this is how to declare a pointer. Next, let's learn about how to assign a pointer. We use the so-called ampersand operator. The ampersand operator can be used to determine the memory address of a variable, which can be assigned to a pointer variable. So now let's check another example here. In the first statement, we declare var1 as an integer variable and initialize with the value 100. Then we use the ampersand operator to determine the variable of var1 and assign it to the pointer variable ptr. So after the execution of those two statements, ptr is now a pointer to var1, and var1 can still be called var1 or the variable pointed to by the pointer variable ptr. So now let's put everything together and have it run by an online compiler so we can see the result in real time so we can better understand. But we add two more output statement in order to check the result. So we output the, the value of a var1 and ptr. Before I run the example, let me use an illustration to explain the concept of pointers again. So first here, we declare a pointer variable ptr as an integer pointer. Then a memory location is allocated for ptr, and of which the memory address is 0x155. Then we declare another variable var1 as an integer variable. So another memory location is allocated for var1, of which memory address is 0123. Then we initialize var1 with the value of 100. So 100 will be stored in the memory location for var1. And then we use the ampersand operator to determine the memory address of the variable var1, right, which is 0x123, and then assign it to the pointer variable ptr. So the memory address of var1 0x123 will be stored in the memory location for ptr. Right. Next, let's run the example on the online compiler. So let me share the screen. All right, here's the online compiler. Actually, I already paste the example code there. So let's just hit the run button. So as you can see here, var1 equals 100 and ptr equals some weird number. Well, it is because now ptr is the memory address for the memory location of var1, and the computer use a hexadecimal number to identify memory address. So that's why you see the hexadecimal number here. Right now, let's go back to the slides. So now you see pointers are a little bit unusual. So you must wonder when pointers are used. All right. The answer actually is centered around the concept that memory addresses can be used as names for variables. So there are two occasions or scenarios to use pointers. The first one is if a long variable is stored in several contiguous memory locations, then the address of the first one can be used as the name for the variable. It will be more efficient. All right, let me use another illustration to show that. So now we have a string hello here, and now we want to refer to it or pass it to a function call. Well, because hello consists of 5 characters plus one control characters, so it is a very long variable. Instead of pass all 6 bytes to the function, we can use pointers. We can just pass the pointers of the first byte. So in this case here, we use the pointer variable ptr to pass the memory address of the first byte of the string hello, and the memory address of the first byte is 1000. So you see 1000 here. So instead of pass all six bytes to the function, we can just pass the pointers of the first byte. That's going to be much more efficient. The second occasion is when a variable is used as a call by reference argument in a function call, then its memory address is passed. And then inside the function, the address is used to access the actual argument used in the function call. So it means the changes are made to the parameter affect the pass argument. All right, since only the memory address is passed to the function. So if afterwards the values of the parameters are changed, then the new value will be reflected and then accessed by the function. So the new value will be accessed. It is contrary to the call by value. In the call by value function calls, the values of the arguments will be accessed only once when the function is first called. Then the value will stay the same during the whole life of the function call. So this is the difference between the call by reference and call by value of function calls. So and those are the two occasions pointers are used. And it will be more efficient to use pointers. Next, let's learn how to declare multiple pointers together. Let's jump directly to the example here. All right, now in this case, we want to declare the 2 pointers P1 and P2 and 2 integer variables V1 and V2 all together. So we can declare all of them with just one statement. So all we need to do is just type like this, and then we just attach asterisk to the pointer variables. So after this declaration, P1 and P2 point to variable of type in integer, and V1 and V2 are variables of type in integer. So this is how you can declare multiple pointers with just one statement. The next interesting operator we want to learn about pointers is the dereferencing operator. C++ use the asterisk operators in another way with pointers. the phrase, the variable pointed to by P is translated into C++ as asterisk P. So here, the asterisk is the dereferencing operator, and P is said to be dereferenced. And altogether, asterisk P can be used as a variable name. So now, asterisk P actually is equivalent to a variable. Next, let's see the example run for the dereferencing operator, so you can better understand. Right, first, we declare v1 as an integer variable and initialize with 0. Then we declare p1 as an integer pointer variable. Then we use ampersand to determine the memory address of the v1 and assign it to the pointer p1. So after this point, v1 and asterisk p1 refer to the same variable. So if in the next statement, if we assign the value 42 to asterisk p1, so the value of a v1 will also becomes a p2, because now v1 and asterisk p1 actually refer to the same variable or the same memory location. Then we use two output statement to output the value of a v1 and p1 asterisk p1. Then we can expect both have the same value of 442. All right. So next, let's run it on the online compiler. So now let me switch to the online compiler. All right, let me cut and paste the sample code. Copy. Then let me paste to the online compiler. All right, now let's hit the run button. All right, as you can see here, v1 equals 42, asterisk p1 equals 442. So that pretty much shows the function of the dereferencing operator. All right, so now let's switch back to the slides. All right, actually, this is the last topic for today. So do you have any question? If not, then I'm going to conclude today's lecture.